Hello, everyone. Thank you so much for inviting me to share my work with the SIGDOG community. Today, I'll be talking about argument mining, discourse analysis, and educational applications, with the latter part of my talk also touching on issues related to multi-party dialogue. So let's begin. I'm going to frame my talk in the context of the following two research questions. First, can general approaches from the area of discourse analysis be used to improve the performance of state-of-the-argument mining systems? So from this perspective of my talk, discourse is going to be used as a way of improving argument mining. You can think of this as an intrinsic evaluation perspective. The second set of questions that I'm going to be asking relate to the following perspective. Can argument mining itself be used as a method of discourse analysis, which in turn can be used to improve the performance of downstream applications, and in my case, educational applications. So here, argument mining itself is the discourse method and will be used in an extrinsic evaluation context. So after briefly introducing kind of my perspective, the definitions that to introduce the topics, the bulk of the talk will be presenting work on two studies that my group has been conducting. The first is a little older, so it's taking a more traditional NLP feature-based approach to the problem. It focuses on the subtask of argument relation classification in a corpus of written essays, and the educational application that it will be used to improve will be automated essay scoring. The second part of the talk will focus on ongoing work that my group is doing in argument mining for multi-party classroom discussions. And this work takes an oral approach. It focuses on a different subtask of argument mining, different type of data, and different application. Here, a teacher dashboard to support teacher learning. So first, what is argument mining? Argument mining is or the argument mining community is a relatively new group within the computational linguistics community that started kind of self-organizing a few years ago and has now been having a set of yearly workshops, often affiliated with ACL conferences. It brings together research in formal argumentation from AI with corpus-based approaches from NLP. And the idea is to view argument mining as a type of discourse analysis whose goal is to process unstructured textual or speech input and output a specific type of discourse structure, namely an argumentation structure. And in turn, what is discourse analysis? I'm sure everyone at SIGDOG already is familiar with this area, but just in case, discourse is the study of sentences in larger context beyond just a single sentence. And what makes a group of sentences a discourse is that they are typically not a random collection, but a coherent group with some sort of structure. There's been a lot of different approaches to formalizing this notion of coherence and structure. The studies I'll be talking about will be building both on work in coherence relationships, discourse parsing, and on linear segmentation, topical coherence approaches. So that's going to be kind of the first approach, discourse for argument mining, building on these general theories of discourse. For the discourse as argument mining, that's going to build on the perspective that argument structure is itself a specialized type of discourse structure, typically at a very global level. As for the educational applications, the first area I'll be talking about relates to automatic scoring of student essays. So here, argument mining involves taking an input text, segmenting it into portions of text that relate to the argument, labeling those, so those are the brackets that you see, labeling the bracketed segments with respect to argumentative roles, things like claims and premises, putting those argumentative ADUs into some larger structure. So that's what you see relating premises to claims via relations such as support and attack, and then going from sort of these pairwise relationships into some global discourse structure. The second set of, the second source of data that I'll be focusing on is from a corpus of transcripts of spoken classroom discussions involving multiple students. And here we're interested again in taking the transcripts, figuring out what parts of the transcript relate to the argumentation, so the segmentation. From those segments, and so you can see in the first turn, student 1 has 3 argument segments. The second turn from student 9 only has 1. For each of the segments, labeling it with respect to its argument roles, such as claim, evidence, or explanation, and then putting it all together in some sort of global discourse structure. As probably you inferred from these informal examples, argument mining is often thought of in terms of a number of subtasks, which can be done either in a pipeline fashion or learned in a joint manner. One task is to take the input and figure out what part relates to the argument, come up with the boundaries of the argumentative discourse units. That's a segmentation task. Once we have the segment, the next task is to classify the segments with respect to the role they're playing with the argumentation. Is the segment making a claim? Is it providing evidence for the claim? Once we have the ADUs labeled with respect to their roles, the next step would be to identify relationships between the ADUs. For example, is a claim supporting or attacking another claim? And a final step is to go beyond what's literally in the input, sort of the argument discourse analysis that you can get from the explicit text, to bringing in inference and other types of information such as common sense knowledge to further complete the argument. Today I'll only be talking about the first 3 steps in the context of the projects that I've been working on. And again, the sort of discourse perspective that I'd like you to remember at the end of the talk is that first, discourse can improve each of these subtasks by enhancing state-of-the-art algorithms with general purpose discourse information, and that argument mining output, which is itself a form of discourse analysis, can be used to perform downstream applications in education and otherwise. Okay, so the first project's related to automated essay scoring. This is an area which, even though it's one of the oldest applications of NLP in education, which has seen a lot of renewed interest in recent years. Part of this is due to the development of MOOCs, which make it very hard for human instructors with so many students to actually grade essays. So people have tried to incorporate automated methods to enable the use of such assignments in that context. But even in traditional classes where one instructor maybe has 30 or so students, it's still a really time-consuming task to provide feedback and to score, and automated methods can be used to help reduce teacher burden in traditional contexts as well. Besides a renewed interest in essay scoring, there's been a kind of newer interest in argumentative essay scoring, both because of increased interest in, for example, in the US, there's something called the Common Core Standards, which has been promoting the importance of this type of writing genre. And relatedly, people have been developing not just holistic ways to grade essays, but analyzing them and scoring them from particular argumentative dimensions. So the work I'll be talking about was done jointly with my now graduated PhD student as basically the core of his dissertation work, where we focus first on using general purpose discourse to improve argument mining, and then using specialized argument mining discourse output to improve AES. Okay, so as I said, the first part of the work I'll be talking about is focusing on discourse-aware argument mining. And in our work, we used 2 sources of discourse information. One was a more global perspective, which took advantage of, we knew the topic of the essays. And the second, which is what I'll be focusing on, is a more local perspective that relates to ideas of linear text segmentation in the NLP field of discourse analysis. And our work, we've looked at the utility of discourse for 2 different subtasks. In today's talk, I'm only going to be talking about argument relation classification and focusing on only the use of local discourse information. So what is relation classification? This is the 3rd step in that pipeline. We've already done the segmentation, shown with the bracketing here, done the once we have the segments, labeled them with respect to their roles with respect to the argument. So that's labeling each bracketed unit with something from an argument ontology, here claim and premises. And then finally, once we have that, that's where argument relation classification comes in, which takes basically any two pairs of argument components or ADUs, one called a source and target and the other a target, because these are ordered relationships. The task of relation classification is first to determine if there is a relation, and if so, what relation it might be if multiple relationships are possible, such as support and attack. For this set of studies, we took advantage of two different corpora. The first is a corpora of persuasive essays, which was made publicly available to the community by a group in Germany. And this is one of the few essay corpora that is available, so it's been used as a benchmark in a lot of studies in this area. And again, for relation classification, we take the raw components which are labeled, for example, with respect to claim and evidence, construct ordered pairs, and then label for each of the pairs whether relationships exist, and if so, what it is. And you can see the distribution in the table, and the thing to note is that mostly there are no relations. So most of the pairs are not going to be connected in a global discourse structure. Because of that, there's also been some simplification to restrict all the pairs that are even potentially related. And here we use paragraphs to make that simplification. The second corpus, unfortunately, is not publicly available, but we had access to it, so used it as a way to examine the generality of our approach. This was a set of APA-style writing by undergraduates at my university. And you can see that it's a much smaller corpus than the first one, but the distribution of the relations is the same. In fact, most of them are not related. We have a slightly different ontology for the relationships, and here we did not enforce this paragraph constraint to limit the number of pairs. To examine the utility of discourse, we wanted to compare our work to a baseline model which largely did not take discourse into account. And for this, we used the state-of-the-art model at the time, which was developed by the same group who actually created the persuasive essay corpus. And it's a standard feature-based approach drawing on lots of different types of linguistic knowledge. The main thing to note is that it doesn't involve much discourse information. So again, we have a target and a source pair, and we're trying to determine if there's a link between them and what that link might be. Most of the features are extracted from only the target and source and ignore the rest of the sentences in the essay. The only type of discourse information that we see are positional information, so it doesn't look at the actual text of the other sentences, but it can look at the location, sort of the index number of the sentences that correspond to the target and source. And it looks at discourse markers that might be present in the target and source. And this is actually a bit misleading in a case where they're not adjacent. For example, sentence 3 begins with the discourse marker as a result, but it's not actually a relationship with sentence 1, it's a relationship with sentence 2, which is currently not available in this baseline model. So the intuition in our approach is we'd like to, when examining the target and source and extracting features, consider other sentences in their local discourse context that would enable us to extract discourse features. And for example, here, when we look at the discourse marker in the source, we would now relate it more properly to sentence 2, which is neither the source or target, but would be in its local discourse context. And as I mentioned, the proposed discourse features we looked at were twofold. One was based on this notion of windows, sort of similar to linear text segmentation. And the second, which I won't be talking about, was based on the topic. And although I won't be talking about the results that I'm presenting when I say discourse, are a combination of both the local and the global features. So the window-based framework, as I said, is that based on the intuition that when considering both the source and the target, we don't want to just extract features from the component, but we'd also like to construct discourse features from its larger text segment. And we're going to make a similar restriction as in the persuasive essay pair construction based on a paragraph constraint. For our work, we looked at two ways of forming windows. One is very simple and is not really informed by sort of linguistic theories of discourse. It's just looking at local contexts. The second, however, is informed by the ideas of building text segments using unsupervised notions of lexical cohesion. And when so the idea is to use either of these approaches to construct a text segment and to have a conflict resolution strategy so that a sentence is only assigned to one segment rather than multiple segments. So for example, given a target and source sentence and some other sentences, we would not only extract features from the target and source as before, but we would first construct windows and then extract discourse features that could take advantage of these windows. Here, if let's say the window size was one before and one after, the source sentence would consist of these three sentences, the target, because if we had the window of three sentences, the third sentence of the target window would be the first sentence of the source window. By our conflict resolution strategy, the target window will be slightly smaller. Okay, and what this enables us to do is once we construct these discourse windows, we can then extract discourse-related features from them. In particular, the sort of discourse knowledge that we're particularly taking advantages are enabled by discourse parsers, both using the PDTP framework and the RST framework, which enables us to look at discourse relationships within windows and across windows. So does this help? So our first set of experiments, we look at one of the discourse approaches, the simpler one, and compare the results of argument relation classification with and without the discourse information. And we do this separately in both corpora. For the persuasive essay corpora, our evaluation uses a training testing split that was used in prior publications. And we tune the window size by creating development data from our training data. Use standard evaluation metrics, F1 precision recall, and because of the class skew, do it at a macro level. And what you can see from our results here, that where there are significant differences between the baseline and the discourse enhanced methods, that the discourse methods significantly outperform the baseline methods. For the academic essays, we use a cross-validation paradigm because the data set is smaller. And we also, in this experiment, use just the smallest discourse window for simplicity. And here we see even stronger results, that in all three cases, the discourse enhanced algorithm outperforms the baseline algorithm. The next question we were interested in was, of the two discourse approaches, did one outperform the other consistently? For this, we use tenfold cross-validation. We give the window size approach sort of its best option by using the best window size, even though maybe in real case we might not be able to get that, but it sort of evaluates the best that could do. And as our text segmentation algorithm, we use the Bayesian topic segmentation algorithm software that's publicly available. And what we can see is that the persuasive essay corpus, the discourse text segmentation significantly outperforms the simpler window-based approach. And the opposite is true in the academic essays, that where there is a difference, well, there was always a difference, and it was always the window-sized approach outperforming the more linguistically informed text segmentation. One reason for this might be that corpus, the academic corpus, is much smaller, and this one actually requires much more of a training, which the simpler approach doesn't. We also can see that the optimal window size is quite different between the two corpora, and that might also interact with the utility of the text segmentation algorithm. Okay, so now let's turn to essay scoring. In the intrinsic evaluation, we were evaluating, at least in the study I just presented, the argument relation classification component in isolation, assuming kind of gold standard input. For the essay scoring study, we're actually going to develop an end-to-end argument mining system, beginning with the raw text and doing all three of the tasks in a pipeline manner. This system we're going to train on the corpus that the persuasive essay corpus that we previously used for evaluation. From an argument mining perspective, this is quite challenging. 402 essays is not very large, and end-to-end performance essays can be propagated, so we would expect that the later components will not perform as well as for example, the argument relation classification did in the intrinsic study I just presented. And also, just to note now, the data that we're going to use to train the argument mining system is not labeled with respect to any essay score, so it's not going to be at all related to the data for the essay scoring part of the work. And here are just some numbers to show the degradation in performance in an end-to-end system. When we have true label inputs, all three components perform fairly well, but when we put them together, there's significant degradation. Nonetheless, we were interested to see, even with so much noise, was there some useful information that could enhance essay scoring systems? So again, we start with the student essay, we run it through our end-to-end argument mining system, we get the argumentative global discourse structure. From that, we're going to extract a set of argumentative features, which we can input to the AES system, and we can do this either alone or in conjunction with other AES features that don't involve discourse, but that have been proposed in the prior literature. We're not by no means the first to have explored the relationship between argument mining and automated essay scoring for argumentative and persuasive essay corpora. What our work contributes to this literature, however, is that we try to investigate lots of areas which people have looked at in isolation, kind of in one very comprehensive study. The corpora for this work, we use two different corpora that are both publicly available to the research community. The first is the automated student assessment prize data that was made available as part of a competition. There are 8 prompts actually for our work. We're only using 2 of them that are related to the argumentative genre. You can see the age of the students here and other statistics about the corpus in the table. The second corpus was created by ETS. It is from a non-native test population. There are 8 prompts rather than 2. And you can see here we have only 3 scores, low, medium, and high, while in the Kaggle data, we have much wider range of score possibilities. And again, as I noted earlier, one thing that makes this particularly challenging is that there's no commonality between these 2 data sets and those that we use to train the argument mining system. Okay, just as in the intrinsic evaluation, we'd like to compare our discourse models to baseline state-of-the-art models. For the Kaggle ASAP data, for this we use a system that was made available, that was one of the highest ranking in the competition. And for the TOEFL data set, we implemented our own baseline based on sort of state-of-the-art features that were available in publications at the time we did this study. What we were proposing, however, to enhance these baselines was a set of discourse features that were extracted from the global discourse structure after argument mining. Overall, we had 33 features. They were based both on prior studies and our own work. And it's not important to look at the 33 in detail, but just to recognize that they come from the output of each of the 3 subtasks in the argument mining pipeline. So the first set of features are based on the ability to segment, just to sort of count how much of the text is related to argumentation. The next 2 are based on the ability to label the segments with respect to the roles. So how many ADUs are there for each type, and both in sort of a unigram perspective and larger n-grams perspective. And then the final set of features are based on having relationships between components and finally a global discourse structure. So let's turn to the results. Our first experiment was interested in seeing, does discourse enhanced argument mining outperform the non-discourse baseline systems? These evaluations, the evaluation metric is quadratic weighted kappa, which is the standard evaluation metric used in the essay scoring community. And here we can see for the two ASAP prompts and the average of the 8 TOEFL prompts. And first we can see that just using argumentative features alone does not outperform the baseline. In fact, it performs significantly worse. And given the rubrics, these aren't surprising because these were holistic rubrics. So argumentation is only one component related to the whole score. However, if we added argumentation to the baseline features, because the holistic rubric does involve some argumentative component, we can see either that we get comparable performance or significantly improved performance. So just like in our intrinsic evaluation, we're showing again that discourse can help improve another task. We also looked at sort of the same experiment, but in a more difficult cross-prompt setting, where instead of training and testing each prompt using data from only that prompt, we now, for example, in the Kaggle data, use prompt 1 to train and test on prompt 2, and for TOEFL, we use 7 prompts to train and test on 8. And we thought that argumentation would be particularly valuable in this domain because the lexical variation and now is much greater between the training and test data. And so we thought that discourse features would be more likely to generalize when lexical cues are not as useful. And we see the same findings here, that only using argumentation features in isolation generally degrades performance, but when added to the baseline features, it can improve performance. Our third experiment was interested in looking at whether the different subtasks, which of the subtasks were most important for feature extraction. In prior tables, what you saw was the experiment where we added all 33 argumentation features to the baseline and did not do any sort of feature selection. But if we in fact did some feature selection on the argumentation features, we could both significantly improve performance and get some insights into which of the subtasks are useful. And it turns out that all 3 of the subtasks, features from all 3 of the subtasks turned up in the final optimal model. We had features just based on identifying the segment boundaries. We had features from associating labels with the segments, and then we had features constructed with finally the global discourse structure from the relational aspects. Okay, so before turning to the next study, just to summarize the results from this set of experiments, we first showed that from an intrinsic evaluation perspective, window-based features based on text segmentation can be used to improve state-of-the-art algorithms for argument mining. In particular, here I focused on the subtask of argument relation classification. Argument mining output, which itself can be viewed as a special purpose type of global discourse analysis, in turn can be used to improve the application of automated essay scoring. And we saw this across multiple corpora and even in very challenging situations where we were using end-to-end argument mining system, which was not sort of the optimal performance that we would have seen if we used the sort of perfect input for each of the components. And even when the argument mining and essay scoring corpora annotations were totally disjoint and led to very different training and testing paradigms. Okay, so I'd now like to turn to my current work in this area, moving from argument relation classification to argument components, so different subtasks, moving from written essays produced by single authors to transcripts of multi-party dialogues, so spoken and many speakers and moving from an essay scoring downstream application to a teacher dashboard application. So first, what is collaborative argumentation? Collaborative argumentation is a method of teaching literacy, in particular in our data from high school English language art classes, where the idea is students read a text, and in order to understand sort of how to analyze the text, a useful way of getting students to do that is to have them read the text before they come to class and then have a collaborative discussion where students make arguments, make claims, support with evidence, and do this by building on the ideas of other students in the class. Despite the fact that people know this is a very important thing to do, it's something that teachers often struggle with. Part of the challenges are that it's very hard for teachers to keep track of how the argument is progressing. Are people supporting claims? Are they building other students' ideas when they're actually managing the discussion and participating in it as well? And furthermore, even if they could do that in the moment, it's hard for them to remember because there's no sort of typically any permanent record of what's gone on. So our work is trying to address these challenges, first by developing methods for mining argumentation, given transcriptions of what went on in a class. And in particular, we're seeing if we can use general purpose discourse to improve state-of-the-art argument mining systems for this new type of data. And then second, to take the output of the argument mining system and to embed it in an application geared at helping teachers monitor and reflect on what's going on in the class as a way of guiding how they might teach future classes. And this is work that I'm doing in collaboration with my PhD student, Luca Lugini, who's about to actually defend his dissertation on this work and other work in just a few weeks. Okay, so the type of discourse information that we're going to use to enhance our prior argument mining work, again, is twofold, and you could think of it similarly to the essay work as from both global and local discourse perspectives. From the global perspective, we're going to take advantage of the fact that we have multiple speakers and they might all engage in argumentation distinctly, and so we can look at a context based on particular speakers. The second work, the local perspective, is very similar to what I had talked about with the essay work, that we're going to look at local windows, sort of ignoring speaker information in this data set as a way of constructing, extracting features that have more discourse and enhanced information. And as I said, in this work, we'll look at the subtask of argument component classification in contrast to the relation classification in the prior study. So just to refresh your memory on argument component classification, we've already done the segmentation, which is identifying the boundaries, and the argument component classification is associating labels with respect to the role these segments play in the larger discourse structure. For this work, the roles they can play are claim, evidence, and explanation or warranting. So claim and evidence are similar to what we looked in the essays, but we also now have added the warranting, which is very rare but extremely important in this particular application area. For this study, we take advantage of a corpus that we recently collected, annotated, and have now made available to the community. You can read about it in the LREC proceedings. For this corpus, we went into 10 local area high schools, into English teacher, 10 different teachers' classrooms, 2 to 3 times, collected almost 1,000 minutes of audio, had the audio professionally transcribed, and then we manually segmented and labeled it. These are multi-party dialogues ranging from 6 students, where we had sometimes the teachers broke the class into small groups, to 29, where the discussion involved everyone who was in attendance that day. I'm going to only be focusing today on the argumentation annotation, but we've also annotated the corpus for some other dimensions, namely the specificity of their argument contributions and how the students collaboratively build the argument. And if you're interested in the corpus, you can not only annotate the data, but as well as the baseline classifiers that we've built and that were in the experiments reported in the LREC system from this webpage. This just shows a little more about the argument annotation in this corpus. You can see that currently we have 3,000 argumentative discourse units. We've recently collected a new corpus this semester, and so we'll be releasing an enhanced version. And every semester, as we collect more data, the corpus that we're making available will become larger. And this shows the distribution of the labels, which shows first it's kind of challenging for an NLP system due to the class queue. And it also shows why we need to build the system, because we can see that students largely make claims and then don't support their claims with evidence. And if they actually do provide evidence, they don't explicitly show the reasoning that's connecting why the evidence is in support or against the claims they make. So sort of changing this, having teachers be aware of these distributions and coming up with activities to try to change them are sort of the goal of the larger dashboard system. For our experiments, just as before, we wanted to see if our prior baseline models for argument mining could be improved by adding discourse information. In our first experiments, the baseline model was the one that we published in the argument mining workshop 2 years ago, which was a hybrid model with CNN and some features from the SpeciTeller software system. In our proposed model, we're going to enhance that feature by adding the 2 types of discourse information that I talked about earlier, based on both the student context and the local context, independently of student based solely on position. So more specifically, our proposed use of discourse in this work is to not only construct embeddings based on the current ADU, but take advantage of other ADUs based on some discourse knowledge of what type of context we should consider. And so our research questions are trying to answer which ADUs should go into the windows and what should the window size be. And again, the 2 sources of discourse knowledge are one based on ignoring speakers based on position, and compared to our prior work, as you'll see, we're looking at more extensive evaluations. Is it that should the windows have utterances before, after, both, and our feature representations for the windows are also richer. That much prior work has used separate representations for the target utterance or target component and the components, the ADUs in the window. For the speaker base, we're exploring this, which is an interesting new source of information that this particular corpus has that many other corpora don't have, either because they're based on only 1 speaker, or if they do have multiple speakers, they don't have the large number that we have in some of our bigger discussions. Okay, so first, does discourse information improve our baseline component classifier? Here we're showing results from cross-validation experiments, and there are a number of things to highlight from this experiment. First, our baseline classifier is the blue line, dotted line at the bottom. And as far as which ADUs should be in the window, we can see that looking at both the prior and next utterances compared to the target ADU, both add value. Which is better depends on the context size, but what we do see is that the yellow ones just looking ahead but not backwards typically isn't useful. As to how many ADUs, we can see that the optimal performance is based on using both prior and next utterances in the windows with a window size of 4, and we can automatically tune this by adding attention to our model. Turning to the speaker type of discourse information, we can see that first, comparing the purple line to the dotted dashed blue line, just adding speaker information alone also adds value to the baseline. And finally, the top line shows that combining this type of discourse with the other type of discourse from the prior slide gives us our best results of all. And then finally, excuse me, the green line shows that the size of the context can in fact be automatically optimized using an attention mechanism. In our most recent work, we've been changing our baseline, replacing our hybrid CNN to BERT, which came out since our original argument mining publication. And we basically replicate the experiment, but just the baseline model has now been replaced. And our results are quite similar. The main difference is that both the baseline and the discourse enhanced models all improve by about 10%, but we still see that discourse enhances the non-discourse model and the similar patterns that we saw before about using both prior and next utterances and speaker and local context. One difference that we see, however, is that our tuning mechanism for attention didn't seem to work on top of BERT, and we're exploring other methods for optimizing the context size. Okay, so turning to the final extrinsic evaluation. Our work in argument mining is part of a larger project called Discussion Tracker, which is an interdisciplinary project with a collaborator, my co-PI from Amanda Godley from our School of Education, her graduate student, and then my two graduate students from computer science. And as I said, the idea is to use the output of argument mining as a method for creating analytics for teachers to help improve their ability to have high quality collaborative argumentation amongst their students. For extrinsic evaluations, we'll be basing it on some initial deployments that we made both this year. Unfortunately, that had to get cut short when everybody moved to remote learning, and an experiment we did the year before where we actually deployed the system 3 times over the course of a semester. And the results I'll be talking about are based on Wizard of Oz versions of the interface, where we use the manually annotated argument mining outputs rather than integrating the automated algorithms before showing the results to the teachers. Briefly, the argument discourse discussion tracker system has a number of screenshots that are seeded by the output of the NLP algorithms. For example, we can show teachers the annotated transcripts where they're broken up into turns, labeled with respect to different speakers. The turns are segmented into argument moves or argument components, ADUs, and labeled with respect to the argumentation output that we talked about earlier. And as I said, there are also some other dimensions which are not the focus of today's talk. There's also options to see historical information. So the idea is teachers use this over time so they can compare how the argumentation varies after different instructional interventions, and they can also use their analyses to plan and explicitly track goals. In addition to that very fine-grained view, we can see these higher level views just to give an idea of the distribution. Again, the argumentation pie chart would suggest that students are making a lot of claims and aren't really backing them up with evidence or backing up their evidence with explanations. This other screen is a way of trying to show how the argumentation argument structure proceeds, taking into account different student contributions to get sort of a global view of the, what's going on in the class over time. As I said, we've only deployed the Wizard of Oz kind of upper bound versions of the systems, and these results are based from a survey after the teachers had a chance to use Discussion Tracker to analyze one class discussion. Unfortunately, as I said, we were intending to do more, but because of COVID, we had to stop after the one. But nonetheless, the teachers were very favorable. 5 is the highest score. You can see all of these ratings are close to 5 and suggest that both the different functionality that the NLP classifiers can be used to visualize are viewed very useful, and that the whole system as a whole, as a way of having them learn about what's going on and facilitating their professional development. Teachers are always also quite positive about that. In the deployment the year before, where the teachers used the system 3 times over the course of semester, we also were able to find some interesting information by interviewing them after they use discussion tracker. So for example, here you can see that after the first discussion, the teacher noticed that they were not having much evidence, not explaining it. The teacher explicitly tried to set a goal to increase that, and they noticed in the next discussion that in fact those properties went up. And the second, this comment kind of reinforces the idea that it helps people having this permanent record, sort of keeping their memory on target with what really went back on when they go back to reflect on the original discussion. Okay. So to summarize, as I said, there were really two takeaways that I hope people will remember. First is that general purpose methods from the NLP area of discourse analysis can be combined with state-of-the-art argument mining algorithms to improve their performance. And this is the perspective of discourse analysis to enhance argument mining. In turn, argument mining, which is itself its own form of discourse analysis, can be used to enhance other type of applications, and I focused on differing educational applications. So this views argument mining as a specialized global discourse analysis approach, which can be used to enhance things like essay scoring. The first point I illustrated with two different subtasks of argument mining, argument relation classification, argument component classification, using two different types of data, written student essays and multi-party classroom discussions. For the intrinsic evaluations, for the extrinsic evaluations, we exploited the output of an argument mining system in two different types of scenarios, automated essay scoring and teacher learning dashboards to support teacher learning. The work in both of these areas is currently ongoing. With respect to student essays, we're now focusing largely on what I like to call temporal argument mining to have students not only get their essay scored, but revise it, and to compare first draft to second draft to third draft, first draft to third draft, so forth, to look at how the argument is changing over time. And if you're interested in that line of work, we have a paper on that at the Building Educational Applications workshop at ACL. We're also interested in moving beyond automated essay scoring to using the output of the argument mining system to generate feedback. So from essay scoring to more broader writing evaluation. And if you're interested in this work, we have a short paper at the Maine ACL conference on that. Finally, with respect to classroom discourse, we're moving that work in a number of directions. Here I've enhanced argument mining by adding discourse, but we're also interested in taking advantage of the other two dimensions that we've annotated our corpus for: collaboration and specificity, and we're exploring this in a multitask learning context. Currently, we do not have an end-to-end argument mining system. Our data is professionally transcribed, and the segmentation is performed by manually by researchers. So we're looking at argument component classification sort of in that ideal case. So just as in the essay scoring work, we'd like to move toward a full end-to-end argument mining system. And ultimately, although it's beyond the scope of our current funding, to not only begin with transcriptions in an end-to-end manner, but actually begin with the speech and use the output of speech recognition as well. So thank you, and I look forward to answering your questions at the upcoming question-answer session. Thank you.